Very simple stuff. Jump to the second one, isolation. I skipped consistency because we're going to go back to consistency and later after isolation. This is one of the longest and, in my opinion, one of the most critical properties a software engineer really should understand. Isolation. What is isolation? An isolation is, to be isolated is I want to stay alone and I don't want to interact with the world, right? Okay, let's take this in the transaction. A transaction is, to have a transaction that is isolated, that means an in-flight transaction, while I'm executing a transaction, can this transaction see other changes made by other transactions that are in flight? Okay, so that's what it means. I am now executing my stuff. Can I see other stuff people are making? Okay, and is that okay? Right? Am I isolated from the other world? Okay, and it's really up to the implementer, the software engineer here, to adjust this knob of isolation that we're going to talk about. Okay, do you want no isolation? I don't care. You can change anything you want and I'm going to read whatever you change, and that's maybe okay. But some cases it is no sir. Okay, we're going to talk about, so that's isolation. Okay, we're going to talk about, as a lack of isolation, you're going to get these read phenomena. I don't know, it's like has a fancy name for some reason. Okay, it's just you're gonna get some read ugliness, read weirdness, right? Some weird stuff while you're reading transactions. Okay, and as a lack of isolation, we're gonna talk about that. Reading phenomena. This is dirty read and all that stuff. And we're going to talk about isolation levels that a database can implement to get rid of the read phenomena. Okay, so without isolation, you get a bunch of read phenomena. We implement isolation levels to fix those problems. Okay, let's talk about boom. Let's talk about the read phenomena. We have 3. I added the 4th one. I don't think it's a read phenomena. It's one of the bad things that can happen as a side effect, but I added it anyway. Okay, so the first one, dirty read. Dirty reads essentially is I am, and we saw that, right? I don't think we saw that, yeah, but essentially, dirty read, what it is essentially is like I am in flight transaction and some other transaction made a change. That transaction did not commit that change and I read that change. Okay, so any minute that transaction can roll back that change, and I just read a bad value, a dirty value that hasn't been committed. That's what it means essentially. Non-repeatable reads, we're going to talk about that. It's like I read a value that is being committed, right? Not necessarily committed or not, right? But then I turn around in my same transaction and I read the same value, whether the same query or other query that give me the same path to that value, like a range query, and I did not get the same result. So my results, my reads were not repeatable in my same transaction. Some users are fine with that. Some users are not fine with that. We're going to talk about that. Okay, phantom reads. I inserted another transaction, inserted a new record, and I picked that up where I shouldn't have picked that up. Okay, it usually happens with range queries. Lost updates is like when you started to change something, right? You changed the transaction, you changed the value, and some other transaction overwrote your value before you even committed. So you're gonna commit a wrong value. So you just lost your update essentially. Okay, and these are the 4 phenomena. Let's talk about each of one of them. Dirty reads. Let's talk about dirty reads. Okay, so we talked about it. Dirty reads. I am going to read a value that hasn't been committed by another transaction. Let's see. I have a sales table here. There's 2 products. Product 1, product 2. There's a quantity of sales. This product 1 has sold 10 units at a price of $5. Product 2, 20 at a price of 4. And I am asked to write a query to produce a report of my sales. So what I'm gonna do is select the entire thing and sum those guys. So product 1 has sold what, $50, product 2 has give us like $80, and then at the end I'm gonna just view the sum of all the sales. Okay, very simple stuff. So to do that, beginning a transaction, okay, even if we don't really need to commit or change, you can also begin a transaction, right? And that can have its values. I'm gonna begin a transaction, selecting the product ID, and then multiplying the quantity times the price, obviously, and then from sales. That will give me what we just saw, right? Product 1, 50, product 2, that sounds good. But here's the trick. While this is executing, another transaction just began, right? And the stock, another quantity, is just added. Someone made another sale, right? And they updated the sales report, okay, where the PID is equal 1. So now we just increase the quantity by 5. That's pretty good, but I don't know if it's good because we just read this. Now I just have an old value, and might be that okay, but let's see what will happen, right? So I didn't commit this transaction 2 yet, right? While I'm doing that, I did the second query, which is select sum quantity times price, which is literally this times this plus sum 20 plus 48. But guess what? This is giving me a wrong result. This is now reading the dirty value that never been committed yet. This guy's reading it. And that's a dirty read, right? We're reading the bad value. Why? Because it's leading to a bad result. See? 50 plus 80 is 130, but I am showing the report 155. So you can see dirty reads are bad. Okay. I'm not saying they are always bad. It's up to you if you can tolerate that or not. If you're building Instagram, for example, you don't really care if the number of likes doesn't match the number of users who actually like the picture, right? So you might, there's a price for everything, guys. We're gonna talk about that, okay? This you cannot just say, yeah, I'm gonna implement the best isolation ever, okay? So there's the read, first read phenomenon, okay? And we commit the transaction, obviously, but it's useless. We got bad results. So that's dirty read. Let's talk about non-repeatable read, okay? A non-repeatable read is, as we said, a read that I'm gonna read something in my transaction and I'm gonna read it again. I'm gonna do two different values. You might say, why are you reading the same values twice? Are you an idiot? Why are you doing that? You just read it. Why are you reading twice? There are, believe me, when you're writing code, when you're writing transaction, you will need to do that sometimes, okay? And we're gonna show you an example, okay? I had to think about an example of this, but here's an example. Same thing, right? Beginning the transaction, I'm gonna select the count of report, right? That sounds good, 50 and 80, right? And then this is the total of this is 130, but guess what? A transaction began at the same time, and it updated the count. Sounds like it's the same transaction, but here's the little bit different I did here. I actually changed that, okay, now it's 15, and I also committed. That's the difference between the first one and that. So whatever I'm doing next is actually not a dirty read, right? I'm reading a committed value. It's a legit value. But the question is, should I read that committed value or not? Okay. So to me, this has been committed. It's a legit value. It's not like the previous one where someone actually rolled back, right? Or could be rolled back. It's not a dirty value. It's an actual committed value. So I'm gonna turn around, do the sum, but now I'm gonna get a bad result. Despite me committing, I get a bad result. So having it committed or not doesn't really matter. Now I got this phenomena of a non-repeatable read in this example because their first read gave me that sum, 130. The second read gave me a different sum. Okay, so that's a non-repeatable read in itself. Okay, so non-repeatable read. So we read this first, we get a result, and then we read it again, we got a different result. So that's a non-repeatable read. We're going to discuss ways to fix this, right? How can you fix this? We can talk about things, how to fix that. Okay, non-repeatable read. right? And obviously you're gonna commit at the end. Phantom read. So what phantom reads is actually interesting because here's an example of a phantom read, right? Let's say I begin a transaction, do the same thing, select and count, and then sum the whole thing. We get 130, 50 sales and 80, right? And at the same time, here's the other transaction, it didn't actually update. It just inserted record. It just inserted a new sale of a totally different product. And now you committed that. So it's changed. It's in the database. And in the same time, the first transaction is still executing. I am selecting all the count prices from sales. That is bad, son. Because now you just accounted for product 3 on the first sheet of your paper report. You did not account for that, right? So now the sum of those obviously is 130, but you're showing 140. Okay, that's a phantom read, and the reason it's phantom read because this is one of that's called the range queries, where you're selecting, but you're getting extra rows. So if we're gonna talk about ways to fix that, this is a little bit harder to fix and to avoid. Right? The previous ones you can implement locks and version controls to get away with it. But this is a new value. How do you lock it? It's a new value. You cannot say, hey, don't read that, right? It's just really interesting. And that one of the ways to fix that is actually serialization, isolation level, right? Let's talk about the isolation levels, right? This is very interesting, guys. I really like this topic. So isolation levels are levels of isolation. Duh, Hussein, what are you talking about? So isolation levels are levels that are implemented by the database to fix those phenomena that we talked about. Okay, and there's a nice table by Wikipedia here that I'm gonna reference here. It's very nice. It just explains the whole thing here. Okay, so read committed is the first type of isolation, which is, I don't know why I call it isolation level. It's that literally offers no isolation whatsoever. The transaction, when your transaction starts in a read and committed way, is not gonna perform any isolation. Any changes to the database is happening, you're gonna see it. So you're gonna get dirty reads here, obviously, because you're just changing everything. You're gonna get non-repeatable reads, obviously. You're gonna get phantom reads, right? And you're gonna get lost updates as well. Okay. The read committed is there is a little bit of isolation here, and most databases implement that. Okay, and most of the time this is the one of the best transaction isolation level because you're happy with that. You're happy to read committed stuff. But here's the thing: each query in the transaction only sees committed stuff at that time of the query. So each query you execute gonna see the new committed values at that time. Okay, and that could be fine, right? Sometimes it is not. Okay, so that's what it means to read committed. You are seeing and viewing the committed stuff at the time of the query. Okay, so anything that's committed, you're gonna see it. Okay, obviously this does not work on our example that we showed because we showed even that is committed, the sales report came out wrong, right? But there are certain cases where read committed is enough for you. Okay, repeatable read, each query in the transaction only sees committed updates at the beginning of the transaction. So here the repeatable read isolation level gives you the ability to see committed values, but not at every single query at the beginning of the transaction. So once you begin a transaction, you will only see changes that have been committed before you started the transaction. Okay, so that gives you a nice isolation tight view, and that's really powerful stuff. So now I'm not gonna go through the implementation aspects of this. Some databases implements versioning to implement this. Like, hey, when you start a transaction, like Cassandra, right? You start a transaction, I am in version 0, okay? And then anything I read is belong to version 0 of the database, okay? So if other transactions are committing stuff, changing stuff, they are updating to version 1, version 2, and version 3. I am only reading version 0. And that gives me a nice consistent view, which we're going to talk about that, right? So repeatable reads, okay? So this way, I guarantee that I'm going to read the same repeatable read, right? I'm going to get the same read because I'm reading the same version, right? Some databases implemented as a form of a lock, which is a little bit more expensive, okay? So you establish an exclusive lock and say, no, I am only reading this. Please, guys, don't change this, okay? Don't change it. So if once we establish an exclusive lock, we cannot, nobody actually can, or nobody can change that stuff. No, sorry, it's not an exclusive lock. So that's right. So the lock approach of that, another approach to implement repeatable reads is you're gonna start, you place a shared lock so you guarantee that nobody can actually change your data, because everybody that needs to edit, they need to establish an exclusive lock to edit these rows, right, that you're gonna about to read. And then once you do that, you release the shared lock, okay? So you implement some sort of a shared lock, but you just blocked people from editing. So versioning is kind of a little bit better there, but there's a pros and cons for each one, obviously. Serializable, that's the easiest way to implement and the kind of the slowest. And the performance goes down with every level of isolation. So it's like, think of it as a chart, right? This is no isolation. This is the highest isolation level, okay? But this is the fastest thing. This is the slowest thing. Because the serializable is essentially each transaction has to be serialized, right? So if you, as if they are serialized, almost like serialized, right? So a transaction just followed by another transaction, they cannot be executed in parallel, essentially. They try as much as possible. The database does a little bit tricky things to execute. Some of them are parallel, but most of them you can think of it as serialized, right? So if you're serialized, nothing running in parallel, you're happy, right? This is the best thing ever. If you're nothing in running parallel, then you're not gonna get in concurrency issue. You don't have isolation problems anyway. Okay, so this is the best way. Most of the time, this is implemented at the application level. The application places a lock and says, guys, stop touching my stuff. I'm updating it or I'm reading it. All right, and then start reading everything, and then it goes away. Okay, that's the table I was talking about with from Wikipedia. You have the read uncommitted level, where all of that stuff, all this phenomena can occur, obviously, because we don't care. Read uncommitted, read anything, right? Any change that happens, dirty reads, lost updates, you get non-repeatable, you get phantom reads. Read a committed, what we're gonna do is essentially read only the committed stuff, so you're not gonna get dirty reads. You know that because you're reading only committed stuff, but you're gonna get non-repeatable reads because each query is getting the new committed stuff, right? So if you queried at the first query of the transaction, and then you turn around and query it again, between those two queries, someone might change the value and committed it. So you're reading the committed value, but it changed. So it's non-repeatable, and that might not be desirable. Obviously, you might get phantoms as well. Repeatable read, you're not gonna get dirty reads because we're reading only committed stuff. But in addition of that, we're only reading committed stuff at the beginning of transactions. So you're not get a repeat. You're not gonna get a non-repeatable reads. All of your reads are repeatable because you're reading the same version of the database at the start of the transaction, or the database will force you to place a lock and then will only read the stuff at the beginning. Okay, so that's essentially a non-repeatable read. But phantoms still can occur as a result because you cannot control new rows. You can only control rows that you can lock, right? And this is debatable. With versioning, you actually can get away with it. Right? So this table is not entirely accurate. With if you implemented versioning with more repeatable reads, you can actually you might get away with repeatable reads, right? If you implement the versioning, I think RocksDB and the Facebook data storage engine implements that versioning. Serializable, best thing ever. I'm not gonna say best thing ever, but if you serialize your transaction, you're not gonna get any of that stuff, right? You are guaranteed that nobody touches anything unless they have a lock, right? So you start the transaction, you place the shared lock, right? And if someone want to implement a exclusive lock, they will get an error because there are shared lock, there are read locks. So, and we talk about shared lock and read locks. I'm gonna reference the video there, guys.